So please remember to return that survey on lecture schedule. Okay, so let's talk about more control flow. You've seen some basic control flows like if, while, for, last, and we'll discuss more. So unless is just if with a negation. So if temperature less than equal to 20 too cold is the same as unless temperature greater than 20 too cold. So you can just treat unless just add a negation and convert it to if. If not hot, too cold, unless hot, too cold. So they're the same. You can also have an else. So you are taking input from standard input, FTD in, assigned to temperature. Trumpet, remove the trailing new line. Unless temperature greater than 20, that is, if temperature is not greater than 20, print too cold, else print too hot. You can also have else if. Unless temperature greater than equal to 20, too cold, else if it's equal to 20, okay. Else, if you fall into this branch, it means that it's greater than 20, strictly greater than 20. So really, unless is really redundant. That's why in C you don't see unless. But somehow they put it in per. So until is another redundant keyword. Sometimes it makes the it's easier to say until something is true rather than while not this is true. So from the English perspective, it reads more like English. That's the whole purpose. It doesn't add anything more expressive than while. So while not in a file, do something. Same thing as until in a file, do something. So it's more natural when you think about it in terms of English. Until loops indefinitely until the condition is true. Initially, response is equal to no. It's a string with the value no until response equal to yes. You keep on doing these two statements. Print wake up, and then taking the input from FTD in, trumpet, come back and compare it to the string yes. Whenever the string is equal to yes, you jump out. So initially, response is equal to no. Therefore, equal yes, this condition is false. So you execute the until body, print wake up, yes, no, and you enter no. Then response is assigned the string no. You come back and compare it to yes, and then execute the body again. You input the y is not equal to yes. You execute the body again until you input a yes. While is just like C++ while statement. People in the back to stop talking. So it loops indefinitely while the condition is true, but the difference is that it always executes the body of the loop at least once. So it's a do while. While response not equal to yes, you keep on looping. However, the difference is that you no matter what happens, you always execute the do body at least once. So for example, if you place a line that says, say, response equal to yes before the do statement, you still go into the do body and do a print and take an input before you exit. So the assignment before the do is essentially useless. So because you check the response string at the end of the do loop. While in the previous example, if you have while on top or until on top, you check the response string before the body of the loop. Therefore, if you have response equal to yes here, it won't even go into the loop. It'll skip the loop body. But in here, no matter what you assign to response, it'll always execute the body of the loop at least once. Do until is similar, just with the while condition negated. So do something until you input a yes and assign it to a response. Always executes the body of the loop at least once. For each, takes a list of values and assigns them one by one to a scalar variable. So loop of the body is executed once for each successive assignment, similar to shell programming's for statement. So for each I is a scalar variable because it has a dollar sign, and this guy is an array or list variable because it has an @ sign. So this is saying take each element of the list and assign it to the scalar variable $I, and then do something in the body. And how many times do you loop is the number of elements in the list. So here's the summing the contents of an array. So A is an array, and for each B is a scalar. For each of the array elements, you add it to sum. Eventually, you get the total sum. So I think we saw another max before, right? In the previous lecture. Okay. Put it in arrays and lists. Right, we saw another max program where you use the more traditional for loop and iterate over the indexes of the array and take each element of the array. So that for each, it's just a more concise way of doing the same thing. So for each, only asks us to print an array in a customized way. So here is, for each I in the array A, print I space, finally print a new line. So it prints out 1, 2, 3, 4, 5. So you can also print, with I colon or something else. So you can customize how you print it. You can also say simply print at A. It'll print out 1, 2, 3, 4, 5 with no spaces between them. So if you have element 23, you wouldn't know if it's 23 or 2 elements, 2 or 3. But if you print out with the space, it's more clear. So print number in reverse order. So remember that reverse is this keyword that takes an array and returns a reversed array based on ASCII order, right? It's not the numeric order. So reverse of 1, 2, 3, 4, 5 is 5, 4, 3, 2, 1. But if you have element 13, it'll be listed between 2 and 1. So it's not counting the numeric value. And also notice that it doesn't change the list itself, the array variable itself. It only returns a new array variable with the elements reversed, but keeps the original array unchanged. So if you print A, again, it'll still be 1, 2, 3, 4, 5. Also, parentheses are always optional in Perl functions, so you can also say reverse parentheses with or without a space between the left parentheses. Both are fine. So if you omit the scalar variable, so for each you omit the $I in here, and simply say print this guy $_ is this explicit variable in Perl that's used whenever you don't specify the variable name. So this is if you do this, essentially it assigns each element of A to the variable $_ and then use it as the argument of print in the body. So this is kind of a controversial feature in Perl because it can make code very unclear. But it can also make things much more concise. So print and other Perl functions use this implicit variable as the default if nothing is specified. So here you are printing each element of the array using the implicit variable as a temporary variable. Notice that you don't have a space within the print. Therefore, you print out the array reverse with no separation space between them. So if you want a double space, you can just say explicitly this guy double quote underscore $_ double space. So that previous example without the double space is essentially the equivalent to printf $_. So if you omit it, is fine. But if you want double space, you have to put it there explicitly, like this. So the scalar variable for each is an alias for each variable in the list, not just a copy. If you modify this scalar variable, it modifies the list. So this is like a C++ reference or pointer, not a copy. So if you do this, this guy star equal true, it means multiply b by true, double the value of b, and then you print it out. It has the print out the A array. It prints out 2, 4, 6, 8, not 1, 2, 3, 4 anymore. Also notice that if you print just add A, it prints out the list without any spaces, a separation. But if you enclose the list in the double quotes, then it prints out the list with a single space separating each element. It's really a language definition in term. So here we have double quotes around the array, so we have 2 space 4 space 6 space 8. So last, we saw last time it breaks out of while until for each loop. It's like the break in C++. For mysterious reasons, do while and do until do not count as loops in Perl. By this, we mean that perhaps the language designer didn't do a good job. It really should treat them as loops, but somehow they didn't treat them as loops. So if response is equal to yes, do last jumps out of it. So jumps to here, outside of the loop. So you do while 1, this is an infinite loop. So you keep on printing and taking response until you get this yes, and then you jump out of the loop. I'm sorry, so if you had a while 1 on top, you jump out of the loop. But do while, because of the really a defect in the language design, it says can't last outside of a block at last 1, line 6. So just remember that it doesn't work for do while and do until. So here's the another example. You have a while in the outer loop and a do while in the inner loop. So it looks really redundant, really weird. So you do a last in here. So if you have an equivalent C++ code, you think that last jumps out to here and you go back to the top of the outer loop. But really, Perl doesn't treat the do while as a loop, so it really jumps out of the outer while loop, because the outer while loop is the on top while 1, so it's treated as a loop. So the last statement causes the outer while loop to be broken because the inner do while is not treated as a loop. Next, causes a jump to the end of the loop, but without terminating the loop. So until response equal to quit or equal to yes, print wake up, take a response. If it's equal to yes, go to next. So next jumps to jumps to here. That is just before the closing parentheses, closing curly braces, which is equivalent to saying that it jumps to the top, jump to the until statement. While if you have the last, it will jump to the end of the curly braces. So look at this. So response is initially equal to no. This until condition evaluates to false. Therefore, you go into the body of the loop. Print wake up. Response is no. So you skip the if statement. Print sleeping. And come back and print wake up. You say yes. Then it goes to next, which is the end of the loop before the curly brace, and jumps back to the top until. And until condition evaluates to true because response is equal to yes, then you exit the loop. So if you enter a quit instead of yes, then it skips the if statement and print sleeping, and then go back to the top until and evaluate the condition to be true and exit. So notice the different behavior if you enter yes or enter quit. Yes, you skip over the sleeping, print sleeping statement. If it's quit, you will skip the print sleeping. So in here, if you if you replace the next with last, it'll have the same behavior. It'll exit the loop, but the control flow is different. If you have a last here, it will directly exit, go to the end of the curly brace without even checking the condition anymore, without checking the until condition anymore. But if you have a next, it goes to the end and then goes back to the top and checks the condition, and then decides if you go out or not. Redo causes the jump back to the beginning of the loop, but without retesting the condition. So here we have a redo. So it jumps back to this guy to print. While in the previous one we saw that if it's next, it jumps to the until, do the condition checking. But here we do skip the condition checking and directly to the first line of the body. Next, retest the condition. So if you enter a no, it will skip the if statement, go to print sleeping, and enter a yes. It goes back to print and executes the body again. So because you don't retest the condition, it will take another round of input instead of exiting. And finally, you type in quit. The if condition, if statement is not executed. You print sleeping, and come back to the top of until, and check the condition to be true, and then exit. Right? Any questions?
If I use for loop and with redo, will it increment any variable in the for loop?
Increment of if you use a for loop, you should use perhaps for 1 that is infinite loop, and then inside you test the condition. If this condition is true, you exit. So there's you can't put this thing inside of a for, right? You can only put for 1 that is infinite loop, or for counting some number of elements. But for this kind of a Boolean condition testing, you should use until or while. So just reiterate. Next and redo only work for a while, until, for, and for each. Not do while and do until. So for some reason they're not treated as loops. So if you do a redo here, while it's within the do until, it'll say can't redo outside of a block at redo line 7. So notice that Perl is an interpreted language, not a compiled language like C++. That is, doesn't have a compiler. It interprets the program line by line. Therefore, when you execute a program, when it doesn't hit the statement, everything is fine. It always works. When you hit the statement, then it gives you an error message. Unlike a compiler, which will tell you that something is wrong at the very beginning. So you can make a while loop out of the redo and last next in a naked block. The block that's not part of a loop or if statement. So this is a naked block. Now, have two curly braces with nothing in front of or after them. So if response equal to yes, we do last. That is to jump out of here otherwise you do redo. That is, you come back to print. So this is really like a while loop, except you don't even have the while keyword. So every time if the response is not equal to yes, you go back to the top and print wake up until you get a response equal to yes. Then you exit the loop, exit to the end of the curly braces. We can also use next here, because notice the difference between last and next. Last jumps to the end after the curly brace, while the next jumps to the line before the curly brace. That is, if you have a next, it'll jump to this point, and then exits. So in here, the point before the curly brace so last goes to the end of the curly brace, and next go to the just before the curly brace. So if you have a while 1 on top of the curly brace, I have a while. If you have a while 1 here, then these two behavior are different. If you have a last, you exit the while loop. If you have a next, you go to here and then to the top of the while loop. But here we don't have a while on top. Therefore, next goes to the before the curly brace and just drops out of the loop. So next and last here have the same behavior, but not if you have a while on top, right? Any questions?
Can we treat it as a loop with a curly bracket here?
This guy had the effect of being a loop. because of the these two statements, last and redo. Right? Redo goes to here, last goes to here. So it's really a manually constructed while loop. What if you want to jump out of two nested loops? In C++, you can't do it. Because you only have a keyword break that jumps out of the innermost loop. You cannot break out of a two nested loops. Well, you can do it with goto, but goto is really a bad keyword that you should avoid as much as possible. In Perl, you can use a labeled loop to break out of the outer loop with this last, next, and redo. And for clarity, it's best to choose label names that are all uppercase letters and digits. This is a convention. You don't have to do it, but it's really for clarity. So you can label the outer loop with the word outer loop, colon, inner loop, colon, before the for statement, or while, or until. Add the label as a parameter to the last without the colon. If you want to exit the outer loop, you do last followed by outer loop. So it'll look up which is the outer loop based on the label and decide where to jump to. So this is a little tricky example. So you have three nested loops. First loop, I1, loops from 1 to 2. Second loop, I2, loops from 1 to 2. Third loop, I3, loops from 1 to 2. And within each one, you do a sum, add I to sum, add 1 to sum. So look at what happens. So first, I1 equal 1, I2 equal 1, I3 equal 1, and sum equals 0 plus 1 equals 1. So your print sum so far is 1. That's the first line. If sum greater than 2, that's false. So you escape the statement of if and come back to the loop 3. On the top of the loop 3, you have I3 equals to 2 now, right? So sum greater plus equal 2. So sum is equal to 1 plus 1 equal 2. You print sum so far 2. So again, if sum greater than 2 is false, so you skip the if loop and go to the end of loop 3 and execute sum plus equal 2. So now sum is equal to 4. So now you go back to the top of the loop 2. Now the indexes are I1 equal 1, I2 equal 2 now. I3 starts from 1 again. So now sum equal 4 plus 1 equals 5. Print sum equal 5. So now if condition is true, sum is greater than 2 now. Your last loop 2, which means that you exit loop 2. You jump to this statement. So now sum is equal to 8. 5 plus 3 equal to 8. So now you go to the top of the loop 1. Now I1 counts to 2 now, and I2 and I3 start from 1 and 1 again. So sum plus equal 1. So now sum is equal to 8 plus 1 equals 9. You print sum so far equals to 9. If sum greater than 2, that's true. So your last loop 2 jump again to sum greater than sum plus equal 3. So now the sum is 12. Right? So now you're at this point, that is the line after sum plus equal 3. That is the outermost loop. And the index is equal to true. I1 is equal to true. Which means that you are finished with the outermost loop. Because the maximum index of I1 is 2. So now you exit the loop 1 and print sum at end equals to 12. Right? So any questions? So it's a little tricky, so you should trace through it after class. So you can also put the if in the back instead in the front. So you have say if equal user equal gate print high bill. You can also say print high bill if user equal to gate. Backward if avoids the having the curly braces. Remember that curly braces are required in the forward if. Unlike in C, where you can omit the curly braces if you have a single statement in the body. In Perl, you always require a pair of curly braces. But if you have a backward if, you do not have the curly braces. At the same time, you have the restriction that there can only be one statement inside the block. You can only say print high bill if something. You cannot have two statements before the if. So the philosophy of Perl's designer is really aiming for conciseness. So this is really like an English statement. Do something if something is true, right? So again, it's a redundant feature, but it helps to simplify certain programs. It's an easy way to exit from a loop. So you say last if something is true, if response equal to yes. So it's the same as the forward if response equal to yes, curly braces last. But this is, you can put it in one line and it's very English-like, right? So you can also use the backward so enter numbers and enter 0 to quit. So initially sum is equal to 0, n is equal to 1. So this guy assigns the input to the variable n, and then adds it to sum. While n not equal to 0, so you enter 1, 1, and then it keeps looping because this condition is true, and it's not equal to 0, and finally we'll enter 0, this while condition becomes false, and you exit the while loop. Again, there's only one statement allowed in the backwards while loop, so you have to put the plus equal and n equals stdin into one line. Cannot read the n first and then do a plus equal n if you have a backwards while. And also, remember that if you have an input number and assign it to a scalar variable, then you don't have to do a chunk. You do a chunk, it'll be the same result. It just ignores the trailing new line if you assign a number. So, simple way of writing if this then that is this. So, you input, you say chunk user equal to who am I. Notice that it's a back quote, right? Back quote means execute the command and substitute the output of the command in its place. So who am I returns the current user name was logged on with a new line. So you do a chunk to remove the new line and check if the user is equal to gauge. If it's equal to gauge, then print high bill. So this is the program we understand already, right? So if something is true, print something. You can also do this. So this guy is a logical AND operator. Why does this work? So as a logical AND operator, consider this statement. If this is true, then the value of the entire expression is unknown because of the logical AND. Only when both operands are true, then you can say that this whole condition is true. So if you have only one true, that's not enough. So you have to evaluate that to make sure that it is true or not. But if this is false, then there's no need to look at that, because the value of the whole expression must be false because of the AND connective. So there's no need to evaluate that, so Perl skips it. So this is called short circuiting in C. So here you look at this condition, user equal to gauge. If it's true, then you have to look at the next condition, that is to evaluate the next statement to print. If it's false, then you know this whole thing is false. So there's no need to look at to execute the print anymore. You just skip it, and so it achieves the same effect as this statement here, but it's just more concise. So look at this. Response equal to yes and last. If response is equal to yes, the condition is true. So you must evaluate the second part of the condition. You execute the last and exit. If it's false, then this whole thing must be false. So there's no need to execute the second part anymore. You skip it, and so you go back to the top of the loop because of the while one as the infinite loop. So you can see that Perl adds a lot of unnecessary, unnecessary features to make things, make your program as concise as possible, as short as possible. So another way to write unless is this. So here, unless temperature greater than 20, which is the same as if not temperature greater than 20, print true code. So we can say this guy, if it's greater than 20, then this whole thing must be true because the logical OR connector, logical OR operator says if one condition is true, the whole thing must be true. So there's no need to execute the second part. If it's false, that is the temperature is not greater than 20, then you have to check the second condition, and you print true code. So notice that the executable statements, the print and the last, they always return true if executed successfully. So you're really using this trick to control whether the next statement after the logical connector is executed or not. You don't really care about the return value of the print or last because they're always true if executed successfully. Okay, so let's go on to core I/O. So we saw this already. Reading from the standard in is easy. So just do assignment. In the scalar context, that is, if the assigned variable is a scalar with a $A, gives the next line of input, or undef if there are no more lines. So no more lines means you hit Control D. So in Unix, Control D is equivalent to end of file or end of input or end of line, end of input. So if you hit Control D, then $A is assigned undef. In the list context, that is, if you assign the stdin to an array variable at A, it gives all remaining lines. So that is, each element is one line, includes the terminating new line. Last line may or may not have a new line depending on the implementation of the car. Different versions may have different behavior. So again, until the user hits Control D. So typically a program will read in one line at a time and process the line. So while defined so this guy, $line equal to stdin reads in one line at a time. Defiant returns true unless its argument is undef. That is, unless you hit Control D. And as long as the line has been read, stdin returns the defined value, and the while loop continues. When stdin has no more lines to read, it hits Control D and returns undef, terminating the loop. So this guy reads in input from stdin, and while it's defined, prints the line one by one. So here's an example of program input and output. So the green text is printed by the program, while the white text is what you type in. So you execute the program, you type in hi, it echoes back a hi, prints a hi, test, prints a test, until you hit Control D, and then the while condition returns a false because defined parentheses Control D returns a false value, and you exit the while loop. So actually, you can do I/O redirection. If you say line 1, input, file 1, what happens is that you recall I/O redirection. If you say this, then you use file 1's content to replace SCD in. And it will read until the end of the file and print it out line by line. And until it hits the end of the file and it exits. So end of file is equivalent to a Control D on the SCD in. So you can read and print lines all together. So you say, notice that this guy, @lines, is an array variable, while $lines is a scalar variable. So now, if you say @lines equals SCD in, then you are reading the whole input. If it's a file, if you do a redirection, if it's the input file, then you're reading the whole file. If it's SCD in, you type in the input on the command prompt and until you hit a Control D, indicating the end of the input, and then it prints out the whole collection of lines. That is high test. That's the difference between if you collect input with a scalar context versus a array list context, depending on how you assign the SCD in. Whether you assign it to a scalar or an array variable. So Perl has a shortcut for reading a value from SCD into $_. If you say while SCD in, this is the same as while defined $_ equals SCD in. So notice that anything that doesn't take any doesn't have any arguments takes an implicit argument of $_. That's the convention in Perl. So chunk is the same as chunk, $_, and print is the same as print $_. Here you want to print each line followed by a new line, so you say print. You say $_ explicitly, or you can omit the whole thing and it'll also work. So $_ is the default for many operations such as chomp and print. So let's try it out. So I think we won't take any breaks. to say so this program, so essentially what it does is it takes the input and assigns the input's std in to a $_, chunks it and prints it with a new line again. So you can also say what happens if you can say print $_ without the new line. So this is fine because every time you read in the std in, it reads in one line at a time. So it reads the line which consists of new line itself, right? If you say chunk, then it doesn't print a new line because you see the next one really follows the previous one without any new lines in between. So the point is that you read in the input, it has a new line at the end, unless you chunk it. So another way to read input is with this guy. So left arrow, right arrow returns a single line in the scalar context for all the remaining lines in the list context. So this guy gets this data from the file or files specified on the command line. So if you say while left, right, greater than, less than, then print. You can provide file arguments to it. Here, notice that this is you don't need redirection, IO redirection anymore. You just say mycat F1 F2. Well, if you have a std in, you can redirect with the less than on the command line. But here you can just type in, and it can type in multiple file arguments. So again, this is the same as print $equal. $equal is the implicit argument that gets the input. And notice that this guy returns a single line of scalar context for all the remaining lines in the list context. Here, if you don't specify anything, you have $_ as the you assign it to $_ which is a scalar variable. Therefore, you're reading input one line at a time. That's why you need a while loop to loop until the end of the file. If you do not specify any file names, then it reads from std in automatically. Here, this is similar to if you say explicitly assign std in, it's a shortcut. So the easiest way to read files, you'll see more advanced ways later. So again, it's a redundant command, but it's used to simplify and shorten make your program more concise. Output to std out, you can you already saw we can use print. So print takes a list of strings and sends each one to std out without adding any characters in between. So this guy prints hi bill, this guy prints hi string followed by bill followed by new line. without anything in between. That is, it concatenates two strings. So you can also add parentheses around these arguments or omit parentheses. Parentheses are always optional. So sometimes you may need to add parentheses, especially when the first thing starts with the left parenthesis. So if you say print this guy 1 plus 1 parentheses, comma, chief bill, it thinks you're printing 1 plus 1, and then it doesn't know what to do next. So it thinks you're done after one print, and the next you get a syntax error. But if you do this, enclose the whole thing in the parentheses, then it's okay. You're printing 1 plus 1 equal to 2, which is an array with a single element true. So we are printing it, which is prints out a 2, and followed by cheap bill, which is directly followed by cheap bill. That is, there's no space between 2 and cheap. And also you can say this, without parentheses, around 1 plus 1. Then it knows that it's a list of strings to be passed to print. Notice that in Perl it's untyped. Therefore, if you pass a number 1 plus 1, it'll automatically convert it to a string too. So it also provides a printf, which is more powerful than print, because print can only print out strings. Printf is just like in C. You can take a list of arguments. Well, its first argument is a format control string, which control defines how to print the remaining arguments. So you can string is $s, integer is %d, and floating point is %f. So this is S is a string because you have the quotes around it, and the number contains the number 1, 2, 3, 4, 5. Real is a number, so you're printing it. This means print $s in a 15-character field. So this guy only has 10 characters, so you have 5 spaces before the string. Print it out. And as a decimal integer, in the 5-character field, so that's exactly 5. So you print out 1, 2, 3, 4, 5. If you say $40, it'll chomp off the first character. It wouldn't be correct. So if you have real, you say 10.2f, then you have a floating point value with 2 decimal places in the 10-character field, and followed by finally a new line. So you have 7, exactly 10 here. So notice that this means that the whole thing has length 10, while the floating point part has length 2. Not the integer part has length 10. The integer part has only length 7 because you have a dot and followed by 2 after the dot. So printf is just almost exactly like in the printf in C. So let's switch gears a little bit and talk about makefiles. This is really to make your project easy, because you're going to need makefiles to do any large-scale development. So make utility helps you to keep track of which modules of the program have been updated and make sure that when you compile a program, you use the latest versions of all the modules. So programs have many source and header files that depend on one another. So after you change a file that other files depend on, you must recompile all the dependent files. So look at this example, dependency graph. So your final target is form.exe file. Obviously on Unix you don't have the exe suffix. It's really on Windows, but make is applicable to it's platform independent. So form.exe depends on slide.o and length.o, which means that you link these two object files together into a executable file. Slide.o depends on size.c because size.o is an object file obtained by compiling slide.c. And length.o is obtained from length.c by compiling it. And length.o also depends on form.h, which means that length.c perhaps includes form.h as a header file. So form.h depends on num.h and tab.h, which means that perhaps within the .h header file, you have included two other header files. So whenever you modify, say, num.h, then you must trace the dependency tree and recompile and recompile size.c to obtain size.o and recompile length.c to obtain length.o and finally relink these two object files into an executable file. So if you have several source files, one header file used by all the source files, after you change the header file, each source file must be recompiled, and header files may depend on some other header files. So if you don't have make, then you must maintain this dependency yourself. You must remember which files include which files. You change something, which file do you recompile? It's very tedious. It's almost impossible for a large project. But make maintains that relationship, that dependency relationship for you. So it makes things much easier. So determining which modules to recompile can be difficult when working on large programs. So make utility automates this process. It looks at dependencies in the file, named make file in the current working directory. You can also name it differently if you explicitly specify the file name in the command line. Dependencies specify a target file depends on one or more prerequisite files. For example, the object file depends on a source file. If a prerequisite file has been modified more recently than its target file, that is by comparing the timestamps, make updates the target file based on construction commands, perhaps a compiler or linker. Make normally stops if it encounters an error during the construction process. So the format is target : prerequisites list, and there's a tab, and then construction commands, perhaps a compiler command. So you must have a tab here. It's required. The target is the name of the file that depends on the files in the prerequisite list. We'll see an example. So suppose you have this dependency here, form.exe depends on slide.o and length.o by linking these two object files together to form a executable file. So you say form.exe That is the target file, colon, colon, size.o, length.o, that is the prerequisite list. So form.exe takes size.o and length.o as its prerequisites. You must have these 2.o files before you can build the exe file. And you have a tab here, and this is the command cc-o. cc in this compiler execute a compiler, and -o means that you are using that as a linker. So you're linking the two object files together. That is, the following arguments should be object files, not source files. So you say construction commands cc-o, size.o, length.o, which means that linking these two files, .o files together to form a form.exe. If you don't have this -o command, it'll put the output into a.out, which is the default for output file name. So here's the more complete makefile. So form.exe this guy is obtained from size.o and length.o by this command we saw before. Size.o is obtained, so that's the dependency here. Size.o is obtained from size.c and form.h. That's the dependency here by executing this command cc-c size.c, which means that you're compiling it, compiling size.c. You don't have to specify form.h explicitly in the compiler command because the size.c perhaps includes form.h. Length.o depends on length.c and form.h. That's this dependency. And finally, form.h depends on these two headers. So notice that you can use the shell command on the construction line. You say cat num.h table.h redirect the output to form.h. So essentially, you are concatenating these two header files and put the output into a single header file form.h. So this is kind of just for illustration purposes. You typically don't do this in the makefile. Typically what you do is you include these two header files, num.h and table.h, in the form.h header file and omit the construction command. So then we modify, say, num.h. The makefile will know that you need to recompile anything that depends on num.h and also recompile anything that depends on form.h. So here's an example, compute.exe. It depends on two object files, and you have this command here, cc output compute.exe. Compute.o depends on compute.c and compute.h. So the command is cc-c compute.c. So calc.o depends on calc.c. Command is cc-c calc.c. This dependency, this whole thing here is optional because make is by default it knows that any file's object file depends on a source file. So file name.o is always dependent on file name.c. So you don't have to specify it explicitly. You can see that we don't have the in here this is required because compute.o not only depends on compute.c, it also depends on compute.h. Therefore, you must specify this dependency because of the extra compute.h dependency. But if you don't have compute.h dependency, only have a .c dependency, then you can omit it. Make your makefile smaller. And clean : remove star.o. So this is the shell script, shell command for removing all the object files. And this guy means that you type in make clean, it will execute this line of remove star.o. So this is very handy, especially if you have a large project with many layers of directories. If you remove .o files, in each directory it can be difficult, but you have a clean command. You can write a script here, shell script, which does all the cleaning for you for any large project. So here's an example. If you type in make based on the previous makefile, notice that you don't have to specify makefile name here because by default it knows that makefile, all lower cases, is the argument. If you have a different name for the makefile, you must specify it on the command line. Say makefile, my makefile. And then it follows the dependencies. So look at the timestamps. You have compute.o with the timestamp January 21st, 1604. Compute.c, which has the timestamp January 21st, 1820. Which means that you have modified the .c file after the .o file has been produced by an earlier, perhaps, make. Then you must execute this line here based on the based on this dependency. Based on this dependency. So because the compute.c has a later timestamp than compute.o, you must compile the compute.c. And cap.o has a later cap.c has a later timestamp than cap.o. Therefore, you must recompile cap.c also. And finally, compute.exe has a timestamp 16.04, and compute.o and compute.cap.o, they both have a newer timestamps because you just created them. Therefore, you must re-execute this command to link these two together and forward to a .exe file. Notice that if after you've done the make, suppose you modify cap.c only and didn't modify compute.c, it will see that compute.o and compute.c has compute.o has a later timestamp than compute.c, which means that the compute.o is up to date, and you only need to recompile cap.c and relink compute.exe. You don't have to recompile compute.c. So this is very handy because for a large project, perhaps if you recompile everything, it'll take you a long time, perhaps half an hour or even more. So if you modify a little bit, only a single file, you want it to recompile very fast. Only recompile what's changed, not the whole thing. So make maintains helps you to to maintain the dependency and minimize the compilation effort. So touch updates the date of a file to now. So if you do a touch, it updates the modification date of touch cat.c to be the current timestamp. We invoked the touch. So when you do a make, it'll recompile cat.c. Notice that you don't have to recompile compute.c and relink. If you touch compute.h, it recompiles compute.c. Why? Because in the make file, you specify the dependency of compute.o depending on compute.c and compute.h. So if you modify compute.h, it'll cause this cc-c compute.c to be re-executed. And finally, make clean executes the shell command after the clean colon command. So, any questions? So this is just a handy utility for you to use to check what directories or files are taking up the most space in your directory. Perhaps you're running out of space. You don't know which directories are to blame. So you can look at df displays the free blocks and number of files in each file system. So this starts from the root and lists each of the file system and prints out the statistics. And du displays disk usage statistics. The number of blocks, each block with 512K bytes. So you say du and then pipe it to head-5, which means that give me the first 5 lines of the output of du. So this is perhaps not very useful because it doesn't sort by size. It sorts only by perhaps du's output is based on file name. So if you say du pipe it to sort and then pipe it to head, you can get the top 5 largest directory or file in under your directory. Okay, so we have some time left, so we'll do some explain some quiz questions. So look at this and perhaps spend a few minutes to work on it, to try to work out the output. Okay, so let me explain it. So n is equal to 0, assigned 0. No is assigned 2 times 5. So what does this mean? It's a string, right? Because you enclose it in a pair of double quotes. So if you have a backquote, a pair of backquotes, it means that you evaluate the expression. But now we don't evaluate it, we simply grab the string. So this guy, it prints out 5 zeros. Why? Because $n is 0. 0 times 5 is 0. Now, because you don't have the you don't have the double quotes, it means that you're really computing a formula. You're computing 0 times 5, which is equal to 0. And then x5 means that you're repeating the string 5 times. Remember that in Perl, a number and a string, you can use them interchangeably. If you use the number 0 in the string context, it's treated as a string 0. So that's why this line prints out 0, 0, 0, 0, 0 5 times. And if n times 2, so n is 0, x2, what does this mean? This means that nx2 is the string 0, 0. If you recall, a string 2 zeros is treated as a true. A single 0 as a string is treated as a false. We have x2, which means that string is 0, 0, so this if condition is true. So now you print this. What is this? This means that a backslash is escape. So it means that you want to print out a single quote followed by a escape, a backslash, which means that you want to print out a single quote and a backslash literally without interpretation. So that's why you get this guy. And finally, this guy is really concatenating two strings together. So n is 0. Not equal 1 means that you append a 1 to 0 to form a new string with the content 0, 1. So you print 0, 1 at the very end. So it's a very twisted example to explain to you the difference between star and x, and also the difference between having the double quotes at the string and not having the double quotes as arithmetic, as numbers. So what if print number x5 is executed? It'll print out this guy. Because no is just a string, so you repeat the string 5 times. So look at this guy. What is the value of n after the following? So this is the easy one. So n is 0 initially. If not n, then not n is true, right? So this guy is executed, n is 1 now. Now if n, this guy is true, 1 is true, so n is -1 now. And finally, n equals -1 plus 1 equal to 0. Right? So this one, I'll let you look at it for 1 minute. So the first condition, if b greater than 10, which is false, so this whole thing is false. The next one is also false. Therefore, this first statement is skipped. The next one, this guy is true. This guy, well, it's true, then the whole thing is true because it's a OR, right? So n is now equal to 1 plus 3 equals to 4. So this guy is true. So you check the second condition. This guy is false. So you check the next condition. Right, no. So this guy, the whole thing must be false because no, the first two are combined together because n has greater precedence power than OR. So you must combine these two first. So these two returns a false. You check the second condition of the OR, which is true. Then the whole thing is true. This whole condition is true. So now n is equal to 4 plus 4 equal to 8. So look at this guy for a few minutes. Anyone got an answer? Okay, so what does this do? So initially n is equal to 4. So what is a square bracket 4? It's undefined, right? It's undefined because a only has 3 elements. So even A3 is undefined because it counts from 0. So only A0, 1, 2 are defined. So undefined, when it's used in the arithmetic context, is treated as a 0. So this is n plus equals 0, which does nothing, right? And then n plus plus increments n, so n is now equal to 5. It comes back and A5 is again undefined, and then n is increment to 6. And eventually an increment goes to 16 and jumps out of the while loop. So any out of scope element for array access returns an undef or 0. This is different from C. If you do this in C, you get perhaps a crash if you index beyond the end of an array. You get a warning. Use of any initialized value in addition in per. You have a warning. So look at this guy. So A is an array 1, 2, 3. And is, what do you mean when you assign the array to a scalar? What does this do? Anyone? So this means that you're taking the size of the array, assigning it to n. So which is 3. So what is this guy? This is the index of the last element of the array, which is 2, because it comes from 0. So this for loop is really this. So now you add ai minus 1, I is equal to initially equal to 1. So I minus 1 is 0, so add a0, and next is a1 to n, which is 3. So now you have 3 plus 1 plus 2. Right? Any questions? Okay. So this guy, so what does this mean? Add a equals to 2. So now we know that $n equal to 4. We know that you're assigning 4 to a scalar variable n. So now you're assigning 2 to an array. So Per knows that the result is that A is a single element list. That is parentheses to parentheses. That's the content of add A. So now you say this guy. So I is initially 1. So A1 is undefined because A has only one element. Only A0 is defined. So when you assign to undefined entry in the list, the Per automatically allocates memory and expands the length of the list. So now A has length 2 with 2 elements, and the second element has the value n which is equal to 4. So after the first iteration, you get A with content 2, 4. As you go back to the loop and you add more and more elements until I equal to 3, and that is you assign A square bracket 3. So now A has 4 elements in it. So look at this one. So here A is a single element list with entry 2. So B is concatenation of lists 5, 4, 7. So what is this? It's true because you're concatenating a list. You shouldn't think it's a 1. You shouldn't think that you're using the size of the list because it's a size 1. But it's used in this context, it's treated as a list. So you take the content of A. If A has 2 elements, you append 2 elements to B. So not the size of A. It's different from when you assign at A to a scalar variable, where it's equal to, it's treated as a 1 at the size of the list. So now you assign this array and to this guy a scalar followed by a array variable. So the effect is that the scalar variable $n gets the first element 5, and following the rest of the array is assigned to add A. So the add A at the end is greedy; it consumes everything else. So now add A contains 4, 7, 2. The last one, so D is equal to 5, 7, 9, 4. Now this guy takes out the third element of B, which is 4, because counts from 0. Second element of B, which is 9, and first element is 7. So 4, 9, 7, and a 5. To assign it to this guy, then $n gets the first one, which is 4, and NA gets the rest, which is 9, 7, 5. Okay, so I sent out an email on this survey as to the lecture schedule. So I gave you 3 options, right? Current schedule and just the schedule to have a midterm on May 8th or 11th, or just a schedule to have a final exam, etc. So look at the result on Tuesday. I'd like to have a simple, quick show of hands as to which one you prefer. So who prefers the first option? Raise your hands. A few? Okay, so the second option? Fewer. Okay, the third option? No one? Okay, I get it. So you don't want to have a heavy workload at the end, right? So, yeah. Okay, I'll look at the survey result and decide later. See you next time.